Hi everyone, are you able to hear me clearly? Please respond via chat. Everybody has to be muted. Great, great, great. All right, so we have a great audience today, and it'll be great if you could introduce yourself while others are joining. Please feel free to introduce yourself in a couple of sentences. And yeah,
Darshan here. I have around 7 years of experience in
please introduce yourself via chat because there are quite a few participants in the session. So I'm extremely sorry to mute you all. And so feel free to introduce you via the chat. Okay. Sorry, Darshan, to mute you. And please introduce yourself via the chat. Great. Great to know you, Darshan. All right. Let me also start recording because this is quite useful. Okay, so I've started the recording. All right. Hi Shailesh, hi Nidhi, hi Shekhar, hi Divyesh. Great to know your backgrounds. All right. Great, wonderful Amresh. All right, nice to know you Gaurav and Jerome. Great. Thank you, Ajay. Thank you, Vikram. Great to know you. And Nidhi, Yashwant. Wonderful, wonderful. So please, okay, okay. Yes, meeting has been started, so we will be. I think Brijesh is not able to hear. All right, good, good. Good to know you, Kiran, Brijesh, Isha, Rameshwara, Abhishek, Ravi. Wonderful, wonderful to know know your backgrounds. Great. All right. So, all right. So a little about me. I did my graduation from IIT Roorkee. I'm Sandeep Giri. I'm the course instructor for CloudX Lab. And I graduated from IIT Roorkee and worked on large scale computing most of my career. I worked with, I started my career with D.E. Shaw in Mobi. Uh, After D.E. Shaw, I joined in Mobi and then I worked with Amazon. And then I'm a engineer at heart and I enjoy explaining technologies. So, and then we started No Big Data and then we started CloudX Lab. We have had a great feedbacks from the users and a lot of good feedback from our users. Based on that, we basically started CloudX Lab to provide learning to the global audience in the big data domain and distributed computing. Great. Great to know you, Krishna, Ravi, and Paul, and Srini, and Brijesh. Wonderful to know you. All right. So we have the other teammate we have is Abhinav. So he's also has been mostly into building products. And now we are working together on CloudX Lab. Okay. So the objective of the course is to learn to process big data with Hadoop and Spark. Okay. Sure, Manoj, you can definitely access. All right. And while covering the course, our primary focus will be to understand the process of processing big data, whether using Hadoop or Spark. Will cover the entire technology stack. Okay. The structure of the course is there are videos. So here we're talking about the self-paced course. So there are videos and there are quizzes and there are something called hands-on assessments. Okay. Hands-on assessment is something which automatically evaluates a particular step. And we are kind of having our own way of assessing users because users are logged in into CloudX Lab. Those who are already member of our self-paced course must have uh, tried hands-on so far, hands-on assessments. So the course consists of videos, quizzes, hands-on assessments, and projects. Along with that, we have case studies. All right. So that's the course structure. And all of this is based on real life use cases. So in the one of the characteristic we have is called automated hands-on assessment, whereby we have built a way to evaluate whether you are learning by doing or not. So here in the assessment, there is a problem statement, and then you have to go to the lab, do the assessment, do the hands-on, and then automatically it gets evaluated. Okay, you have to come back and click on I'm done, and it will do the evaluation. All right. So under your My Courses, you can see the various courses available, and under each course there are individual playlists or topics, you can say. and you can learn them end to end. So that is something which we have. And each learning item that you see here is can be a video, can be simply text, or can be an assessment, or a composition of all right, or it could be hands-on assessment. Okay, so the content that which is not an assessment, you have to click on mark done manually. Otherwise, for the automated assessment, it will automatically mark as tick once you are done. All right, so those who are part of the self-paced course, they would have experienced by now. So now let's talk about the the today's session. Okay, all right, good. So today we are going to talk about big data with Hadoop and Spark. And all right, great to have you in the session, Christopher and Deepak. And great. All right, all right. So again, welcome to the introduction to big data and Hadoop and Spark. So feel free to ask questions because the live training course is all about asking questions. This is the course which we are starting after 3-4 months, after a lot of people asking for the live training. And this session today is the first one out of 14. First one is open to all. So there are around 100 participants, and that's the reason that's the reason today we are just going to cover the introduction and overview. All right, so those who are already aware of big data with Hadoop and Spark Stack, the introduction, the basics of it, they, it'll be very simple for them. It'll be very obvious, so it may not be very useful to you. All right, so you can if you find it very simple or very obvious, then please feel free to drop me an email or message me, and maybe join the full live course, which has 14 sessions, and this one is the first one out of it. All right, so again, it's a the objective of this session today is to make people aware of what does it mean by big data, Hadoop and Spark, and why do we need all of these. Okay, we'll focus on more on the case studies and more on general awareness, and we'll also try to answer your questions. Okay, so feel free to ask questions, and I'll try to answer whenever we get a little more time. All right, so before jumping into big data, Hadoop, and Spark, let's try to understand the data variety part. This is something very important. All right, this is something very important. So data is generally classified, vaguely classified, you can say, into structured, semi-structured, and unstructured. All right, structured means that we know what are the fields in the data and the data type of each of the fields. Okay, for example, you have a database table. In a database table, we clearly know that these are the columns and these are the data types of each columns, right? And thereby, since the data is well structured, we can simply use a very high level language like SQL in order to process such data. Then the second kind of data that we deal with is unstructured data. Unstructured data is the other extreme where we neither know the fields nor we know the nor we know their data type. For example, plain text file, whereby we need to process this plain text file in order to infer the fields and their data types. All right, and that's unstructured data. And in the midway, we have semi-structured data, whereby we know these are the fields, but we do not know the data type of each field. We do not know the data type of each field. Okay, so that's semi-structured. Example of semi-structured is CSV file. CSV file is comma separated file in which the rows are separated by new line, and inside the rows the values are separated by comma. Now, to understand the data type of each field, we generally have to process or use an external application to figure out the data type of each. Okay, just give me a second. All right, can you hear me? Uh,
Hello.
yes.
Hello, Paul. I am able to hear.
Okay. Do you still hear the echo? All right. Probably somebody might have turned on their mic, and because of those reasons. All right. Thank you, everyone. Okay, great. All right. All right. So please stop advertising yourself, and yeah, because that'll lead to the removal of a lot of people. Okay. So we want everybody to see each other's comment. That doesn't mean that you will advertise here. All right. Please do not spoil the experience for everyone. All right. Great. Great. So can somebody remove Vikash from here? Okay. All right. Good. So let's focus on, we do not want to spoil everybody's experience in the session. So let's focus on, learning today rather than, advertising each other. Great, great. All right. So in order to convert an unstructured data to structured, before the tiny break, we were talking about the structured and unstructured data. Right? And so generally, the raw data that you get for processing is unstructured. Could be text, could be anything, right? All right. Is everybody able to hear me? Because I fear that not. Great, great, Paul. All right. So in order to convert an unstructured data into structured data, we need to do processing. And this processing is generally called extract, transform, and load, ETL. All right. So ETL, even though there are many tools available right out of the box, but when it comes to big data, most of those tools are not able to scale, and for that we need newer tools. Okay, and that's why we are talking about big data. Let's go ahead and we'll so one of the use cases of these technologies is to do the ETL. Great. All right, so we have all right so we have as we go forward, most of these tools, the so-called big data tools, whether it's Hadoop, Spark, or others, they're mostly distributed. Now, before understanding any of these tools, let's try to understand what does it mean by distributed systems. Okay, so a distributed system is basically groups of networked computers that interact with each other in order to achieve a common goal. In order to achieve a common goal. Okay, and therefore they therefore all right. So again, I'm kind of getting distracted with the comments. All right, all right. So a distributed system is groups of networked computers that are interacting with each other over a network in order to achieve a common goal is known as distributed system. In a distributed system, there are many computers and they are connected over the network. They're connected over the network and a program or a goal is divided amongst these many computers in order to process. All right. So the other form of computing is parallel computing. We will talk about parallel computing in a while. And okay, the parallel computing means there is a single computer and there are many processors, and all these processors are interacting with each other over via RAM or via another memory. So that's parallel computing. There's a very thin line difference between parallel computing and distributed computing. Okay. So a quick question: how many bytes are there in 1 petabyte? Just first answer, and we will move quickly just to check if you are paying attention. Yes. 1 to the power 64 is actually 1. Yeah. All right, Raghu. Great. Great. All right. Great. Thank you, everyone. Yes, that's right. So it's around 15 zeros, actually. It's around 15 zeros. Another question to you is, do you have any idea how much data does Facebook store in one day? Anybody? Interesting, interesting. So they approximately store around 600 terabyte data in a day. Although this number could be varying because we are having a secondary source of information. Okay. All right. So you can see that when we talk about data, when you're serving to a larger customer base and the amount of data that comes in is really, really high. Okay, and so now let's get back to the definition. Why do we need a definition? So that we can stick to the same understanding across the course. Okay, so that we can stick to the same understanding and we all are agreeing for the same meaning of the big data. All right, so what does it mean by big data? Yes, in very simple words, data of very big size. In very simple words, big data is nothing but data of very big size that you cannot process with usual tools. All right. All right. Data of very big size that you cannot process with usual tools. And to process such kind of data, you need distributed architecture. You need distributed architecture. And that's what is big data. All right. So the data could be of any kind, structured or unstructured. All right. So what is big data? Data of huge size that you cannot process with usual tools. When I say usual tools, it's your usual database, usual file system, usual ETL tools. And for accomplishing the task, you require distributed computing or distributed architecture. Data could be semi-structured, unstructured, or structured. All right. Great, great. Now, the other point that we generally want to understand about big data is that the three general characteristics, one, volume, velocity, and variety. Volume means the data at rest. Okay, so here we are trying to talk about when we classify something as big data, or we classify something that this cannot be processed using usual tools. What could be that trigger? What could be that characteristic of the data that's making it unprocessable on the or using the usual tools? It could be its volume, it could be its velocity, and it could be its variety. We won't go into the other V's right now. We will, because those are secondary, so we'll try to understand these three first. Okay, so when the storage becomes a problem and you realize that the storage cannot be performed using a single computer, no matter what we do, then we call that the volume characteristic is causing this data to be big data. And second one is the velocity. Velocity means when the data is, when your problem is because of so many requests or because of the data movement, and you cannot solve that problem using a single computer, and you say that you need a distributed computing solution, and then we say that the velocity characteristic of your problem of or your data is making it big data, right? The third one is variety. Variety is an interesting aspect. Variety refers to variety of problems as well as variety of data, right? So most of the processing problems involve a simple transformation in which the amount of time it would take is proportional to the number of records. But but as more and more kind of processing or more and more kind of need arises in the industry, or more algorithms are coming up, the output, the time taken to process a particular data might not be proportional or linearly would not be having a linear relationship with the input data. And that's what we call, that's where the the complexity arises. That's where the complexity arises, when your need is to do something which takes far more number of CPU cycles. For example, a machine learning problem. Machine learning problems are not linear. It takes more and more and more and more computing. And thereby, or in other words, if your data is complex, as complex as say Facebook graph, for processing such data, it would require more CPUs, more number of machines, and so on. Possible it won't be possible by using a single machine, or no matter which tool do we use. Therefore, the variety could be in problems involving complex data structures such as maps, social graph, and recommendations, and so on. All right. All right. Good. Good. This is a very good question by Gaurav. By velocity, would you club both updates to existing data and new data together? And is big data good in handling both? It's an important question, so I would love to answer it now. So, so when we talk about velocity, mostly we are talking about the situations where the main problem is handling lot of flowing data. It could be related to, for example, um, streaming videos. Right now, we all are in this session and there are around 116 people. So, right, there are around 116 people, and the video that will be streamed is 116 times the one which I'm uploading. So to do this kind of work, to stream so much of data simultaneously at the high speed, you require you require a decent amount of computing. All right. So, and some problems could be a composite of all three. Some problems could have bigger volume problem, bigger velocity problem, and bigger variety. So, so your problem or your data could be big data, or your problem could be big data problem because of any of these three, or any one of these three, or more of these three, right? All right, let's move on. Yes, Gaurav. So yes, so my answer to Gaurav's question would be that most of these big data tools are, the way you design is in order to handle both volume and velocity, and you try to understand the problem and then accordingly choose the components. All right. Christopher's question is, in real-time environment, do we want all transactions to be handled in linear time? So very good question, Christopher. Christopher's question is that in real-time environment, do we want all transactions to be handled in linear time? We try to do that. We try to do that mostly, but not all transactions can be done in a linear time. Okay. All right. Venki's point is in between any exception, how big data will handle. So it depends on each individual tools. So big data is not a tool. Big data is just a characteristic of data. All right. Just a characteristic. There are many tools, whether Hadoop, Spark, and many more. We will go over each of the tools very quickly and give you an idea of what does each one do. Manju's question is, does high velocity data demand parallel processing? Mostly yes. Mostly yes. Most of the high processing demands, as in when you have millions of users or thousands of users trying to access your real data stream or producing so much of data that you want to handle it in real time, in those all cases you definitely would like to go for either parallel or distributed or a combination of all right. All right, so we will talk about the other tools later. Great, there are many tools that are there to process big data, Nagraj. All right, and yes, now so the volume part is pretty easy, where the objective is just to store data, while velocity part is little harder to notice is when number of requests are just too many. For example, when you when, if you think about Facebook, there are millions and millions of users continuously updating their news feed, right? You keep on refreshing your Facebook page, or there are so many users trying to watch the YouTube video and so on. Then the third one is variety part. There are, imagine that there could be a scenario, where the problem is complex, even though the data is small. For example, think about this problem at hand. Let's say you have to find a map. You have to find a way from one place on earth to another, right? even though even though the data of map could be in 100 gigabyte, right? But since the problem is complex, problem involves iterating through all possible paths and figure out the problem of finding the shortest path involves iterating through all possible combinations of paths. Therefore, the problem, the problem of finding map is is actually a big data problem, even though the data might be small, even though there are not too many requests coming in, even though there is no volume or velocity, but problem such as finding map or finding page rank, we'll talk about page rank later, or going through the social graph, even though the data might be very small, but just because of the complexity of the problem becomes a big data problem. All right. A quick question to all, just to check if you are aware of this part. How much time does it take to read 1 terabyte from a hard disk? Yes. We are talking about 1 terabyte. All right, great, great, wonderful answers. So let's assume the hard disk is of very small, standard speed. Great. So it takes around 6 hours. So all those who have answered around 5 hours, around 2 hours, or 10 hours, they're actually closer because that variance would happen between disk to disk. Okay. So it would take theoretically around 6 hours time. So we are directly reading the data from the disk connected to the motherboard. All right, via say SATA or some other cable. Yeah, thank you, Nikhil. All right, so it takes around 6 hours. Okay, so now here we talked about 1 terabyte data. Just reading 1 terabyte data is taking 6 hours. And we are talking about Facebook creating 500 terabytes data per day, 600 terabytes per day, right? So if you think about that way, the amount of data that's coming in, if it's a single computer, it can't actually, and remember that writing speed is further more slower than the reading speed. Okay, so you can't actually write 1 terabyte data in a day on a disk. Therefore, disk speed is one of the major concerns and major reasons to go for the big data kind of solutions because of the volume problems. All right, now a question from Varun. It's a very interesting question. Question is, do big data servers use hard disk or SSD? They use both. All right, and as an engineer you will have a choice to use both of these. And what does it mean by hard disk and SSD? Hard disk is the older way of storing data, in which it was like a cassette. It's a magnetic tape in which there's a header that moves, physically moves, while SSD is a electronic chip. SSD is a chip whereby, just like the RAM in the memory, an SSD is far more faster as compared to hard disk. And SSD is very less prone to failures, while hard disk is prone to failures. SSD is costly, therefore SSD is actually far more costlier than the normal hard drive. Therefore, for storing too much of data, SSD cannot suffice. And thereby, there has to be a composite of hard disk and SSD in the real kind of scenarios. Thank you, Paul. Yes, that's right, Paul. And Akanksha's point is that what does it mean by reading 1 terabyte of data? Is it like opening 1 terabyte file in hard disk? Yes. So there could be many files, there could be single file, and so on. All right. So there could be many files, let's say 1,000 files, each of 1 gigabyte, and you want to read that. And and let's say if it sounds very hypothetical, let's say what you want to do is every day you just want to count number of vowels in all the data that you have received. Okay. So for that, you don't need too much of processing. You just have to go through all the characters that are there in the data. And for that, only bottleneck will be the disk. Okay. Thank you, Christopher. I'm happy that you got the idea that why do we need distributed computing. Yes. So basically, one of the main reasons for distributed computing is the hard disk. which takes so much time to read. And it takes even more time to write the data. All right. And the irony is that most of us who are coming from a computer science background, we we have dealt only with the memory. We have hardly dealt with the disk. Okay, all the entire data structures, algorithms is based on the in-memory computing, not from the disk. Okay, that's why there is a need of learning new form of computing. All right, in which we try to distribute and we try to process data, keeping the disk reads and everything in mind. All right. So if you have to just count vowels in 1 petabyte data every day, do you need distributed systems? Do you need a big data solution in order to just count vowels in 1 petabyte text every day? Yes. Good. Good. And I'm very happy that most of you agree at this point. Great. Great. So yes, Paul, because of the volume characteristic, since we need to search the complete data, and we are not really searching, we are just scanning. We are just going from one side of the disk till the end, looking for vowels and counting the vowels. So if we have many computers doing the same thing for 1 terabyte data, it will be far more possible, 1 petabyte data. And 1 petabyte is 1024 terabyte. That means 6,000 hours of a single computer. All right. So 1 petabyte is 6,000 hours every day. Okay. If you have to do it every day, you can't really use this kind of thing. A single computer cannot do this. You need many computers, their ability to read data in parallel, and so on. All right. Great. Great. So this is standard graph which shows that the data has been growing really fast since 2002. Exponential means the data in the rate of increase increases with the existing data. That's why the data looks exponential. Okay. Now, so since 2002, after probably this new era of tools and technology, we'll talk about it, the data has been expanding really fast. All right. And the question at this point is that why did that happen? Why are we talking about big data now? Why is it important? Why and why did big data happen, or why did so much of data got produced recently? The answer is multifold. One, devices. The devices became cheaper, faster, and smaller. The smartphone that you use for playing Angry Bird, or the smartphone that you use for, you know, using the Facebook, is far more faster than the supercomputers of 2000s. Okay, so the smartphone has become really powerful, and that's the and that same thing has happened with other devices as well. And because if you talk to anybody from the hardware domain, you will come to know that their objective is to make a device that is cheaper, faster, and smaller. Cheaper, faster, and smaller. Every hardware company, they keep that KPI, key performance indicator, as cheaper, faster, and smaller. And because of which, more and more devices have so many sensors as of today that they produce so much of data. Smartphone has camera and so many other sensors which capture more and more data. Second reason for big data is connectivity. Connectivity, as of today, we have Wi-Fi, we have 4G, we have NFC, we have GPS, and so on. There are so many modes of communicating data. And when we communicate data, the data increases. The data increases. And that's why I've put a multiplication sign next to the devices. So the data produced by devices get multiplied by connectivity. All right. And how? By the way of so many applications. All right. So a combination of devices, connectivity, and software engineering leads to leads to so much of data. And that's why the data has been increasing exponentially. All right, now a little bit technical. Question is, to process the data, what all components do we need in a computer? Let me just, make it very simple. Try to make it very simple. One is CPU, of course, right? So the characteristic that matters for us is how many instructions a CPU can handle per second. That's the CPU speed. The second characteristic is the RAM. The second component of a computer is RAM. RAM is random access memory, and we will always say memory instead of saying RAM. Okay, so in this memory, we keep the data that we want to process, and CPU reads quickly from RAM. And why do we do that? Because RAM's speed is far more faster than the disk. We can read data from RAM at a blazing speed and instead of as compared to the disk. Okay, so how much RAM we have and what kind of a speed do we have makes a lot of difference in the computing. And to your surprise, to your surprise, while scaling any server, or while even your own computer, it'll be the RAM that makes the biggest difference. Okay, so earlier in the previous times, like few maybe say 10 years ago, the entire agenda was to increase RAM of servers so that they can become faster and cater to more number of users. Now the third component which is very important is hard disk drive or SSD. These are the permanent storages. Problem with RAM is, even though, is my voice clear to everyone? Because Varun and Raz are not able to hear. All right, it's clear to everyone. Good. All right, so we have permanent storage called as hard disk drive or SSD. The problem with RAM was that whatever we stored, it was only transient. It, as soon as the computer turns off, whatever is there in the RAM disappears. All right, now that's why we needed hard disk or a permanent storage. And recently we have moved to solid state drive. SSD means hard disk drive and SSD means solid state drive. Solid state are faster but very costly and smaller in size, while hard disk drives are cheaper and bigger in size but slower. Okay, so the fourth component that matters is the network in the computing. This is something, a new addition to to the definition of a computer called network. Network, why does it matter in computing? Okay, it's a hard question to answer. One reason is almost every application that we deal with in today's time talks to the network. Second reason is that when we cannot store data in our hard disk drive, we generally push it to the network computer on another computer. And if that network, the physical network is slower, then reading from the other computer will become slower, and hence the computing will become slower. Okay? So as the data grows, at least one of these four components will become such a bottleneck that you will have no other solution than going for a big data architecture or a big data solution. Okay, for example, let's say we are talking about a problem like map, or we are talking about a problem like Bitcoin. The problem there is the CPU would become bottleneck, right? So, and sometimes the RAM, the memory, the amount of memory that you want to process continuously, that becomes a bottleneck. So at least one of these components will become a bottleneck, and thereby you will say that now we need to move to big data or a big data processing. So this is the way the computer engineer looks at a processing, that and this is what we do mostly. Let's say that there is certain kind of data that we need frequently. What we'll do is we will create an index that essentially means a lot of it would come into RAM, or we will cache it. We'll prepare a caching layer that again will bring data from network or disk into RAM. Okay, or we will do the multi-threaded programming utilizing the CPU and so on, or we will write a better algorithm that trades off between CPU and memory. Okay, so we basically play around with these four components. Christopher's question is, which component usually becomes the bottleneck link? So actually any of these four could become. And as an engineer, we will try to move the bottleneck from one to another, but eventually we will realize that we need to move to a distributed platform. But generally, the bottleneck starts with the RAM. Okay, the bottleneck starts with the RAM. All right. Now, a question to all of you. I think you can answer this one. Which components, which of these factors impact the speed of computing? Which of the factors impact the speed of computing? Wonderful, wonderful. Yes, all of these above. Great, great. All right. Now that was little too technical for today's session. Now let me come back to a very important point. We talked about so much of data. We talked about reasons behind the data, but what's the point? Why do we need data in first place, right? Why is there such a need or desire to accumulate that much data or try to process that much data? The answer is very simple. More data, better insights. For example, let's say we are computing the average heights of people. Okay, the bigger the data set, the better will be the value of average, right? The bigger the data set, the better will be average. Earlier before we had that much capability of computation, what we did was we used sampling mostly, and sampling had their own problems, right? If you read in statistics, there are sampling biases, there are other kind of problems. So sampling is just a hack in order to get the right predictions, right? How many times you would have seen that the small, what do you call the, before the polls, there are these predictions. Uh, they are based on a small samples, right? Therefore, the better or the bigger the sample or the better the data, better will be insights. Okay, one of the insights is the recommendations. It is very useful to both Amazon as well as the end user, right? There are many kinds of recommendations. Okay, let me just check. All right, great. So great. Is everybody seeing the same screen? E-commerce desk recommendations. Yes, great. Question from MSP is, which technology is behind Amazon's recommendation of products? So honestly, before Mahat came into play, we had our own algorithms. Now, after the point Hadoop came into play, Amazon started a group called Amazon Machine Learning, and there we had kind of you know all the products from Hadoop ecosystem under that umbrella. So we started using Mahat for a brief period for recommendations, and before that we were using the proprietary one, and now they have moved to something else. Okay, okay. A question from Amresh is, what role does AWS play? AWS essentially provides the storage. It's more like outsourced systems to somebody, right? It basically provides a cloud-based platform to store data and to run computing. Okay, there are many services under AWS umbrella, and most of them focus around infrastructure. All right, good. So one of the very good use cases of data is recommendations. What is recommendations? Recommendations are basically understanding somebody's choices and then providing some suggestions. Okay, like in the childhood, we discussed with our friends what kind of movies they liked and what kind of movies I liked, and then we reconcile and figure out that since we are similar to each other, therefore we might like each other's movies, right? Or we are so dissimilar that we should not pick up each other's movies. So that's exactly the science behind recommendations mostly, that we try to find the similar users and do the cross recommendations. Okay, so the recommendations are many kinds. One of them is hand curated. Other is people who bought this also bought that. The third one is understanding the entire behavior of user and then matching the correct movies. So those are the various kinds of recommendations. And how do we generally do it? What we do is, in one of the examples that we would go through, we will take a data set of movie ratings from movie lens and use MLlib, although we provide an example from Mahat also, but that's self-paced, that's not part of the live. And we basically try to produce the movie ratings. Okay, in one of the examples, what we will do is we will actually try to get movie ratings for each of us. Okay, so that's an interesting exercise, and that's an interesting exercise in which you will learn how do we do the recommendation using Apache Spark's MLlib. So Apache Spark provides a library called MLlib, which has all the algorithms required for producing recommendations. Okay. All right. The second data consumers are A/B testing. These are just few examples, tiny few examples. Almost everybody wants is the consumer of data as of today. The other use case that we would like to discuss is A/B testing. What is A/B testing? Let's say you have a website and you want to understand what works better, which kind of header is better, green or red. Okay. So instead of fighting this war of opinions, we zero down on the data. And the A/B testing is core of Amazon, Google, Facebook, and almost everybody who has quite a few users. To an extent that if you want to implement A/B testing on your website, there are many tools. For example, Google has also made it open a tool to do the A/B testing of your website, and you can use that for your website and understand how many users are liking the variation A and how many users are liking the variation B, right? Which of the variation is producing better sales that you can figure out with A/B testing. At Amazon, we did A/B testing like crazy, and we almost every decision on Amazon detail page. I was working with Amazon detail page, by the way. I worked there for 1.5 years. So every tiny little things, we took the call we took the call based on A/B testing. Every component is having multiple variations. And therefore, if you think about all possible combinations of the various features on your website, on Amazon's website, there are many. So there are many A/B testing, uh, many variations. There are many variations running at this point of time at Amazon. And to manage all of that, to manage the statistics of all the users and understanding which particular feature is making it sell better or which improving the engagement, to understand all of that, we need a data platform. All right. The other big data customers are government. Government does the fraud detection, cybersecurity, welfare, and justice. They basically utilizes the data in these kind of use cases. Although there are many more use cases, the other customers are already the telecoms, and they try to figure out why customers are leaving them based on customers data, how many calls did they make, what kind of signal they had in past, and so on. Telecoms also use data for network performance optimization, meaning based on the traffic, which where should be more capacity, where should be more towers, and so on. So the other one is calling record data analysis, and then understanding the network, the behavior of network to predict failure. So there are many use cases for various industries and where the data helps. So the general thumb rule that industry has learned already is, let's start recording the data. Let's not purge it. Let's not delete it. Let's keep it. Let's generate as much as data as we can. We know that in a long run, the data can be utilized. And thanks to the big data revolution, that people today are able to store too much of data, quite much data into say Hadoop or HDFS or so-called data lake at a very low cost. All right. The other big data customers are healthcare and life sciences. These are just few examples. And anything to do with healthcare and life sciences, every information is of a very huge scale. So whether it's health information exchange, gene sequencing, or healthcare improvements, or drug safety. All of these problems are of huge size. All right. So yes, MSP's question is, please show us end-to-end real-time scenarios for better understanding, as many are beginners. So actually what I'll do is I'll share you a blog in which we start at a point and we do the end-to-end. Okay. If you look at our cloudxlab/blog, you will find it, cloudxlab.com, and then you click on the blog, you'll find something called Spark-based dashboard that will give you an end-to-end view. Okay, here I'm going to try to simplify a little bit more. Okay, or all right. So let's take a case of health information exchange in which multi-parties have to share the information, and the information has to be presented, processed, and formatted correctly. And to store the health record data is itself a big challenge, right? So, all right, great. So now the question is, how do we achieve this? If you think about, let's say you planning to build a simple health information exchange, questions that would arise is, where would we store data? How do we process data? And how would we present data? So for those kind of needs, we require big data platforms where there are many big data solutions. One is having a stack of Hadoop combined with the Spark so that you could store as well as process together in the Hadoop ecosystem. The second is that if you know that you are going to store only one kind of data, then you can go for the databases like Cassandra, MongoDB. But if you are okay with moving your data from your premises to say some third party, or we call that cloud is nothing but a computer at somebody else's place. So if you're okay with moving your data from your internal network to outside, then using Google Compute Engine or AWS could be a good solution. All right. Now, we are going to focus as part of this course, we are going to focus on the first one, Apache Hadoop and Apache Spark combination. Okay. And why it's important? Because whatever concepts that we discuss as part of Hadoop and Spark, it will kind of cover the entire distributed computing. We will talk about NoSQL databases, we'll talk about various kinds of mechanisms such as Zookeeper. We'll talk about a new programming language like Scala. And we'll focus a lot on breaking down logic into distributable parts. Okay, we will talk about that. All right. So sorry, you'll have to go to cloudxlab.com and then there you will find the link. Okay, those who are wondering about our previous one, no big data, that will also run parallelly. Okay, so we are having both the website nobigdata.com and CloudXLab. A question from Amresh: what advantages does Apache Hadoop and Spark have as compared to other tools? Very good point. Very good point. Amresh. So while Apache Hadoop combined with Spark provides the entire ecosystem, it has a storage, it has a processing engine, it has a machine learning library, it has the SQL library, and so on. While if you're going for Cassandra and MongoDB, what you get is kind of semi-structured data storage. Okay. And not every problem can be solved by using a database. Sometimes you need a file system, sometimes you need to execute your own program, and so on. All right. So the advantage of Hadoop and Spark over Google Compute Engine and AWS is Google Compute Engine and AWS is that okay is that you don't have to transfer your data to Google Compute Engine if your data is internal, and it's hard for a company to move their data from their internal premises to outside, such as Google Compute Engine or AWS. Okay, let me let me answer some more questions before you lose interest. Question from Christopher is, how old is Scala? How old is Scala? Scala is actually around 10 years old. Okay, Scala started as a project to optimize Java, and it was just a different Java implementation in the beginning, and then it basically kind of became a better language over a period of time. Okay, so it's kind of lesser, I mean less, you have to type less while using Scala as compared to Java. Also, Scala provides you a command line interface to interact with, and it's easier to express a logic with Scala as compared to Java. So those who wanted something like something between Java and Python, they'll love Scala. Okay. A question from MSP. In between, you took something like data lake word. Could you brief about data lake? All right, good question. So there is a concept called data lake, meaning preparing a place where we can ingest all kind of data. Ingest mean transfer or upload or move or place. Okay, so data lake is a place where we can store all kinds of data, all kinds of formats of data from different kind of sources, whether structured, semi-structured, or unstructured. So that's the term we use for data lake. A common mechanism for using data for data lake is to use Hadoop distributed file system. All right. A question from Yashwant is, what is the difference between processing of data using a Spark and Scala? So Spark provides ability to process all kinds of workloads, while Impala is mostly good for real time. Okay. A question from Paul. How different is R from Scala? Okay, so R is actually pretty old language, and R is little slower than what Scala is. Most of the functions that you find in R and which are faster, they're actually implemented in C or C++. Okay, so R is a high-level language which utilizes in which most of the libraries are written using some other language. All right. A question from Satish. I think the new functional language is Golang, which is comparable to Scala. That's a very good point, Satish. Yes. The only advantage of Scala over Golang is that any program that is compiled with the Scala will run on Java virtual machine. Okay. Therefore, you do not require Go compiler, or you do not require a new compiler on the server. Therefore, a language like Scala is quite useful. Hitesh's question is Storm better than Spark, and how? Okay, I'll try to be very brief in this question. There is a component called Storm and there is a component called Spark. Both are used for processing data. Okay, both are used for processing data. in real time. Real time means when the data has velocity and the data is coming at faster pace and you would like to process data as quick as possible. In those cases, either you will use a component called Storm or you will use a component called Spark Streaming. Streaming is just a one part of Spark. So let me quickly compare Storm and Spark. So Spark is a bigger suite of applications, right? It has got machine learning library, it has got streaming, it has got SQL engine, and so on. While Storm is only great for one kind of workload, that is real time. While Spark is capable of batch-wise as well as real time. But Storm is super specialized tool for real time. Therefore, it can give you the results. It is good for processing data lesser than a second. If you want to process data in the windows which are prepared in milliseconds or sub-second, then go for Storm. If you are okay for while processing data, so while processing a fast incoming data, what you generally do, you gather the data in small buckets, right? And then you process it and then you save it somewhere. So if your need is that you want to process it less than 1 second, you want to create these windows or you want to create these buckets in lesser than 1 second, then you go for Storm. Otherwise, you use Spark Streaming because Spark Streaming is a bigger suite of applications. A question from Sitaram is, if we know R, how difficult it is to learn Spark? See, Spark will be very easy for you because Spark mostly is because to learn all of this technology, one of the things that we expect is person to know a little bit of operating system, that we actually put it as part of free course as well. Second, we expect the user to know a little bit of SQL. Third, we expect the user to know any programming language, just basics of it. Just you should have done some programming even 10, 15 years ago, that's okay. Some experience. So therefore for you, it'll be quite simple, quite easier to deal with Spark if you are already comfortable with R. Okay. The only thing you need to understand is the distributed computing part of Spark, because what matters in case of Spark or any big data tool is understanding that we are distributing computing. Okay, that's the most important part, and that's what we teach across this course. All right. Otherwise, we always get these buffer overflows, cannot execute this on this kind of cluster, and so on. Okay, that's where we found that most of the people struggle with when dealing with big data. Mostly not able to properly distribute their workload. Okay, a question from Jin Wang. What is platform programming language directly use Spark, Scala? Yes, that's right. Spark is written in Scala. All right. So Deepak's question is, regarding distributed machine, it follows master-slave architecture. Any other popular architectures? So there are other architectures than master-slaves, whereby the master and slave are, master is elected automatically. But mostly, wherever we are having whether processing or storage, mostly at a execution level, the system is master-slave. All right. A very good question again from Jinwang. Is it possible to apply original R functions packages to data frames uh, distributedly stored on Hadoop? Very good question. So Jinwang, that's where Spark did a clever thing and came up with something called Spark R. Okay, Spark R does exactly what you're saying. All right. Yeshwant's question is our PC memory processing speed capable to practice the Spark? It is good enough, but what you will struggle with is you won't be able to rationalize the need of a distributed computing. Okay, that's why we had set up the cloud-based lab so that people can realize that there are many computers and we can divide and distribute our work. Okay, so it's like using the server and client kind of architecture on the same machine. And if you have to just exaggerate a bit, if we need to learn computing on many computers, utilizing many computers, and that's what is the big data computing is all about. All right. Yes, Ravi, we will be going through each of the Hadoop component, and that's what is the next step. Okay. All right. So we'll start with what is Hadoop discussion after this. We'll focus a lot on that. Okay. So a question from Hitesh is, what is Cloudera Spark 2.0? So there was Spark is an open source solution, and it's basically Cloudera has put Spark inside their component. Similarly, Hortonworks has also put a variation of Spark inside their components. So they both are basically using the same open source solution in order to complete their offering. Okay, it's an open source free component. Everybody is able to use it freely. All right, Abhishek, if you if you can drop us an email at reach us, I would love to answer this question. This question is something. Okay. All right. Uh, okay. So Abhisham's question is, I am 3 years experience in Java and we do not have a big data technology in our company. Now I want to move to a company where I get a chance to work on any of the big data technology. What do I need to do? No. Good point. So basically, what I understand is that if you want to learn big data technology, the right way to start with Hadoop and move to Spark. And in the industry, people understand that part, that getting an experienced person in a newer technology is harder. Therefore, you always get a chance for the interview and eventually get hired. Okay. So even though you may not have an experience directly on big data, but but if you work on it using a real environment like CloudX Lab, basically a cloud-based lab, you will get a real experience and you will be able to learn big data properly. A question from Dravya. Please, can you continue with next slide? Take a question at end. So, Dravya, I would like to answer people's question because they would lose in interest if I do not answer, and also I would lose the context. So please bear with me for the benefit of all of us. It's better that I answer most of the questions now. I had waited for like 1 hour to answer the questions. So I would love to answer questions now and after at the end of session. Okay. And you should keep on asking questions as and when required. I'll go through your questions again and would again, try to respond to you over the email. Okay. A question from Ganesh Ram. Most of the chemical factories are now adopting to the paradigm of real-time machine-made decisions to adjust process variables. What technologies here best suit the requirement? A good question, Ganesh Ram. So most of these are basically, so if you think about most of these processes, They are basically sort of machine learning, whether it's a small trying to extrapolate variables or many variables are there in a factory or industry. So most of it is a part of machine learning. And in machine learning, as of today, I can for sure say that, okay, all right. So I can for machine learning, I have seen that most of the users are either using these libraries on their own machines. These libraries like NumPy, SciPy, all these machine learning libraries, or if their data becomes bigger and their problem is harder, they generally move to Spark MLlib. Okay, so that's my short answer, although this question requires far bigger a treatment. Okay, all right. Zinwank, I would love to answer your question, maybe over email, all right? Because your question is decently advanced and may not be suitable for all others. Okay, thank you, Saris. All right. The question should be visible to all of you, right? And correct, it says Ravi to everyone. A question from Ravi is that hearing that MapReduce is going to sunset, so learning Spark and Scala will suffice. Yes, that's right. So see, learning MapReduce wasn't a bad deal because the same concept apply in Spark MapReduce also, right? But to learn Spark MapReduce, you don't necessarily need to learn the traditional MapReduce. Okay, so it's kind of okay to skip Hadoop's MapReduce and use the Spark MapReduce. All right, all right. So good, good. Please feel free to ask questions, and I'll move on now. And okay, is the purpose of Hive, Kafka, HBase same? Good question. Actually, this is a very common question, and based on the marketing pitch, every component looks the same, right? Every component looks the same, and it's very important. So can I park your question, Ravi? Because I'm going to describe each of these components going forward, and then we will be able to answer. Same is with same is with Drivya. What's the difference between Hadoop and MapReduce and Spark? Could you remind me to answer it after I describe both the stacks? Okay. A question from Haris is that why is MapReduce going to sunset? Basically, MapReduce is slower than Spark MapReduce. Okay, Hadoop's MapReduce is slower than Spark. Also, Hadoop's MapReduce was little more architecturally difficult to program to, while Spark's way of computing is little easier. So that's the reason why people are no longer trying to develop new applications in Hadoop MapReduce. Okay, good, good. All right. So after the break, we are going to go over the entire Hadoop stack, briefly describing each component, and then we will describe the component of which are part of Spark, and that'll be the second half. Okay. So let's take a break for 10 minutes. Okay. I'll be back by 9:41 p.m. IST. Okay. All right, everybody, I'm back. Should we start now? All right, great, great. So before the break, we discussed the general aspect of big data. Now we are going to particularly understand the Hadoop and Spark stack. Okay, feel free to ask questions. There are a couple of questions which I have not answered yet. Please ask those questions again once we cover those topics. All right. All right. So is everybody back? Can we start now? All right. Please respond by the chat. Wonderful. Wonderful. Let's start. So far we have discussed is that we need a distributed platform. Why? Because bigger data means better insights, and there are problems that require inevitably storing or handling a lot of requests or a lot of data and solving complex problems. Therefore, we need a distributed computing platform. All right. So we talked about 3, 4 solutions. One was Hadoop plus Spark Stack. Other was using NoSQL solutions such as Cassandra and MongoDB. Other is cloud-based platforms such as Google Compute Engine or AWS. All right. Out of this, the most complete solution is Hadoop combined with Spark. All right. So what is Hadoop? Hadoop was created long, long back, as in 2009, by dog cutting. It became popular in 2009. Dog cutting. Who was working in Yahoo, and he was trying to work on his personal project called Nudge, which was basically a search engine. He was joined by Mike Caffarella, and at this point he was stuck with the existing limitations of existing tools. So while dog cutting and Mike Caffarella were trying to build Nudge search engine, they were stuck with they were stuck with the the basic tools. They realized that the existing file system, database, and other tools cannot really help them build a huge search engine like Google. And lucky for them that Google released those 3 papers: GFS, GMR, Google File System, Google MapReduce, and Google Bigtable. These 3 papers. Based on that, based on that, Mike and Dog created Hadoop. They named it after the toy elephant and made it open source under the most liberal license, Apache. Apache is just a license, and Apache is just umbrella for hosting many more applications. And there are many great tools under the umbrella of Apache, including Apache Server, which is the de facto web server. And then there are many more tools under the Apache license. Okay, so they made it open source under the most liberal license, meaning that if you want to use Hadoop, you take it and use it. You don't need to pay anybody anything. Okay, whether you are using it for commercial use, or you're using it for research, or you want to bundle it with your own product. So for those kind of scenarios, Hadoop is, although it doesn't make sense to bundle Hadoop because it's not really a library, it's more like a big platform that needs installation separately. Okay, so it's an open source tool for It's an open source tool, and that's one of the reasons why Hadoop became so popular. The adoption became very, very easy. Okay, specifically, if you want to build a solution in today's time, right? A solution that lets people store data, people will be very apprehensive about taking your solution if your solution is not open source, right? So for adoption, most of the tools in today's time are open source. Okay, so it's powerful, popular, and well supported. All right, it's kind of framework to handle big data. And as of today, it has become a big umbrella term to host other applications. Apache Hadoop itself has become a big umbrella term. And all the components under this umbrella must have these three characteristics: distributed, scalable, and reliable computing. Okay, every component which has to be part of Apache Hadoop should be distributed, scalable, and reliable with respect to computing. Apache Hadoop is written in Java, and most of the components that are almost all of the components which are under Hadoop's umbrella are written in Java. All right, this is the view of the various components under Hadoop ecosystem. We start with the file storage. As we talked earlier, that it took a long time to store data and to read data using usual file system. Therefore, the first component that Hadoop guys implemented was file storage, which is Hadoop distributed file system. This file system is based on Google file system. And in this file system, basically, we break down the files, not we, as in Hadoop breaks down the files into smaller pieces and spread it on multiple machines. Okay, we will go into more details. The advantages of this file system is that it can let you store really humongous files. It can let you store really humongous data, and it can let you read a single file, the various parts of it parallelly. It can let you read various parts of the single file parallelly using many machines. That is the beauty of Hadoop distributed file system. Okay, now you can understand that that's the fundamental thing. Like in a normal computer, after the operating system, the next thing that comes is the file system. Or you can generally, file system is actually counted as part of the operating system. Okay. Similarly, for the Hadoop kind of ecosystem, the baseline is the component on which all other components stand is Hadoop distributed file system. All right. Then we have resource manager. Then we have resource manager. What is resource manager? A resource manager makes it possible to run anything on a cluster. It lets you manage the resources, like which computers are free, which are busy, and so on. Resource manager does not provide you any storage. Instead, it depends upon the yarn. The yarn depends upon the Hadoop distributed file system. So you interact with yarn in order to get the work done on many computers. Okay, so but since yarn is like a framework, is a very flexible framework, to interact with yarn, you will have to write programs. You will have to write software, because interacting with yarn is more sophisticated and requires more detailing about distribution of work. Okay, yarn can distribute any kind of work in the cluster. If you have hundreds of machines and you want your work to be distributed, you will use yarn, because yarn keeps track of who is free, who is busy, and so on. Okay, so that's the second most important component in the Hadoop ecosystem. First one was file system, other one was yarn, which was, you can think of yarn like operating system on which you give a program and it executes in the network. Okay, on many computers. All right, now since parallel to yarn, we have something called HBase. HBase is a database kind of thing, right? Like you have usual databases which store data in the files. Similarly, HBase lets us store data in the form of tables. Okay, and that table under the hood is being saved on many machines by the way of Hadoop distributed file system. Okay, which means which means the uh, HBase can utilize the power of file system in order to store many more machine, in order to store petabytes and hundreds of petabytes of data. Similarly, at the same time, HBase lets you handle thousands of requests per second or per milliseconds. Why? Because HBase can run parallelly on many machines. Okay, so this database called HBase, which lets you store data in the form of files, in the form of tables. Okay, this database runs using yarn on many computers parallelly so that it can cater to many requests simultaneously and can store humongous data, and under the hood it's creating the files in the HDFS. Just like when you use MySQL, even though you are creating tables, under the hood MySQL is creating data files in the file system in the same way. Okay. Yes, George. HBase stores data in only HDFS. Okay, so it's kind of very strongly tied to the file system. Although there are ways, by the way of running programs with HBase, it is possible to store data elsewhere. Okay. So a question from Akanksha, can you repeat HBase? HBase is a kind of a database which lets you store data. Data could be semi-structured, okay? Data could be unstructured, right? You can keep the entire 1 GB of movie in a particular column and cell, okay? So in HBase, you can store unstructured, semi-structured, or structured data. And HBase runs on many computers simultaneously, so it can handle many requests simultaneously and can store petabytes of data happily. Okay. All right. So I hope that answers your question. Gagan's question is, it's very important to take the questions right now, and I like to take the questions right now. Gagan's question is, what exactly is NoSQL database? Can you give an example how it is stored and how do we query? Okay, so NoSQL itself is a big topic, and let me try to be very brief and try to see if I can make a point. Okay, so the databases, as we said, are the tools which could not suffice in handling huge data. Why? Because one, database had so many constraints and so much of hard structure that creating a record was heavy and took a lot of time. Similarly, at the same time, databases generally ran only on one machine, making it impossible to distribute the load. Therefore, the idea of NoSQLs came into play, which were basically which are basically trying to be distributed databases. A database that runs on many machines and uses many machines to store petabytes of humongous data. Okay, and the way we query depends on each database. Some databases try to provide SQL kind of language, like Cassandra provides CQL, which is very much like that, while MongoDB is an example of NoSQL like Cassandra, like HBase, MongoDB, Cassandra are the examples quickly. So we will cover these details in one of the courses, in one of the sessions in more details. And MongoDB, instead of providing SQL kind of language, it provides you something called aggregations. So the query varies from database to database. Unlike in the case of RDBMS, unlike relational databases where all of the relational databases let you query using structured query language, using SQL. Grija's question is Yarn similar to Zookeeper? We will come back to that. I've answered Hitesh's question. Gaurav's question is, did you say that you need some software to communicate with Yarn? Just wanted to confirm. So mostly since Yarn is a decently complicated architecture, you generally need to write code in order to interact with Yarn. Therefore, therefore, there is one more layer of components that come that there are one more layer of components there are one more layer of components that have come, such as Spark and MapReduce, with which you can easily write your logic and they will internally talk to Yarn and distribute your work. Okay? Sekhar's question is, can you please tell something about CloudX Lab? Definitely. CloudX Lab is started with giving the lab for all the people. And at that point of time, we were running No Big Data, where we gave these kind of trainings to people. But then, in order to reduce our overhead, we merged the two things together. And as of today, while CloudX Lab is used by other instructors as well, which we make sure that we do not mingle the data and we keep it separate. Similarly, we do provide a lot of content to our users, so that they can learn and practice with us. Okay, CloudX Lab is a hosted environment where you have Hadoop, Spark, machine learning tools, all new AI tools, and so on. All of those tools available immediately right away on the cluster. Okay, and you get a workspace whereby you have a home folder where you keep the data. Similarly, you have a home folder in HDFS where you can keep the data. Similarly, you can keep the data in HBase. Okay. Yes, I will throw some light on Scoop as well. Okay. All right. So a question from Amresh. What programming language do we use to communicate with Yarn? We generally use Java, but good part is that we hardly ever talk directly to Yarn. We either talk via MapReduce or via Spark. So we program for Spark or we program for MapReduce. Okay, and lucky part is that we mostly don't have to really program. We can query using high level tools that we cover right away. Okay. Divyaj's question is, data is stored in HDFS, then why HBase is called data store? Is it an engine? It is basically providing UI structured way of storing data. While HBase, the HDFS only has the raw data store. Exactly the way MySQL also stores its data in the file system, while MySQL provides you a tabular way of doing things. Right? If you're using Oracle, Microsoft SQL, or or MySQL, all of those actually store the data in the local file system, right? In the same way. All right, great. Thank you, Abhinav. All right, now moving ahead. The next thing is a compute engine. As I talked about that you cannot really, it does not make sense to write an application for yarn because it requires a lot of mechanics. Instead, we use a little higher level tool like MapReduce, where we only explain our piece of logic instead of the underlying mechanics, right? We write two functions, map and reduce, and using that, we kind of utilize sorting on a humongous data in order to divide our work on many machines. Okay, so that's MapReduce, because MapReduce is great for the sorting means ordering data, right? Ordering data like group by. If you group by the data, that's basically ordering the data under the hood, right? So MapReduce is like a very simplified way of computing. And under the hood, MapReduce basically utilize yarn and HDFS in order to run your logic. Okay, so the next is Spark. Spark is a sophisticated environment for performing big data computing. It lets you describe your data in the form of something called RDD. This RDD is generally distributed on many machines, and for you, it's like a big array. And then you write your logic in the form of map, reduce, and other transformation and actions, and it executes it very seamlessly. So Spark and MapReduce are kind of competing environment, just that Spark is far more sophisticated while MapReduce is kind of um, a classic or traditional way of getting humongous data computing. Okay, so Yarn made it on top of Yarn. You can run many other kind of frameworks. Okay, so Storm also runs on top of its Yarn and so on. All right. So if you want to really code and want to process data, you will have to learn the Spark and MapReduce. Spark or MapReduce. Okay. So we'll focus when it comes to computing, the programming, the development, we'll focus more on Spark as part of this course. And we will just cover MapReduce to a size where you can dig by yourself. Okay, so we'll cover the basics and overview, and we'll give you the entire material for MapReduce, but we'll focus more on Spark as part of this course. Okay, the next interesting part is SQL. People realize that writing code for even simple work is not possible. Writing MapReduce code for simple works is not possible. Therefore, they created engines like Hive. So you write your logic in the form of SQL that get converted into MapReduce, which get executed by Yarn. Okay, so you write your logic in SQL. Hive converts that SQL logic into MapReduces, and MapReduce under the hood runs on Yarn. Yes, Varun. Yarn Resource Manager is used for both MapReduce and Spark. A question from Vanki. What's the use of Storm API at Hadoop? Good. So there are certain kind of computing where what you want to do is there is a fast incoming data and you want to process it continuously. This kind of data is called unbounded data set. This data set never ends. For example, processing Twitter's feed. That's unbounded data set. It never ends. It keeps coming, you keep processing. The program never ends. These kind of applications are called streaming applications. Okay? And for that, you use either Spark Streaming or you use Storm API. All right? Good. Gaurav's question is Hive, does Hive converts only to MapReduce or Spark to it converts only to MapReduce as of today? Okay. But Spark makes it possible to talk to Hive and other components. Okay, because Hive lets you define a database table, and that database table gets stored under the hood and so on. And you will understand this part as we do more hands-on and when we interact more. Okay, so Hive is an SQL interface, and basically it lets you define kind of tables. The data is lying on HDFS or other sources, and Hive lets you write these queries which gets converted into MapReduce and get executed on top of Yarn. Okay, so that's our SQL interface. The other interface, Pig Latin, which was quite interesting, and mm, is actually now not being used much, is Pig Latin. Pig Latin was very interesting idea whereby you write. It's basically a very simplified SQL. Pig Latin is the language. Pig is the converter text, which takes this Pig Latin and converts it into MapReduce. Okay, so Pig Latin is SQL-like interface. All right. And although it's not being used much because of the language limitations, but the idea which Pig Latin came up with, whereby you define a graph of things and execute it, that idea, lazy evaluation, is something used in Spark as well as in other newer platforms. Okay, so it's basically for simplified computing. Okay, so although it's not being used, it's largely replaced by Hive. Yeah, so Piglatin is largely replaced by Hive, and so we will also kind of give an overview for legacy regions of Piglatin and focus more on Hive in this course. All right, so Drivya's question is when to use Hive and when to use Pig. So here the answer is very difficult to do because most of the work that can be done with Pig can also be done with Hive. And we generally use Pig only for legacy regions if somebody wants to, really is using Pig Latin. Okay, Gaurav's question is, so if MapReduce sunsetting, does it mean Hive and Pig go away as well? Just curious. So Hive would stay because there's no overhead in maintaining MapReduce. Okay, just that maybe Hive will come along and implement something which runs on Spark. Okay, right. A question, very good question from Hitesh. For making a web application, how is Spark linked to the web page? Okay, should I get the result from Spark SQL and then store in HDFS to feed it to web page view? Okay, so for catering to a web page, right? Why would you, let's say you're building a web application. So I was part of the Amazon detail page. So you're building this highly highly available web application like Amazon's page, like for the one that gets served on the browser as well as served on the mobile. Okay, so there the need was a web framework. There was a web framework, but the other need was to have a NoSQL data store on which most of this data is pushed into. So in case of a website, we generally do not need any of these components except for a NoSQL database like HBase or Occasionally, let's say there is a data lying in big data system and you would like to take out the statistics and display it to the user. In those cases, Hive exposes a Hive server port to which you can query and get the data. And when you query, it'll create MapReduce, run it on many servers, and give you the results. Okay, that is how you would use the the big data in your web application. Okay, do I make sense to you now? So, okay, let me rephrase my question. So his question is that how is Spark linked to the web page? As of now, Spark, though it has come with Spark server, but still that's still in a beginning phase. The way people do is they create kind of a third-party servers, maybe a Hive server or some other, and use Spark to populate that database. Okay, when you are catering to the end user, you would not like to run a batch process, specifically on big data. Reason being, the request might take a very long time. All right. So for web application, what you do is, let's say you would like to, okay, let me take a step back and explain again. It's a very interesting question and more people will be able to benefit from it. Okay, let me try to answer Hitesh's question from the beginning. So when we talk about linking Spark to a web page, let's think about it other way. How do we link big data to a website, right? Question is hard because while on your website, when the user is coming in, you would like to display something instantaneously, right? Instead of making the user wait. For example, Amazon detail page would like to display the recommendations. Recommendations are not computed on the fly. Instead, recommendations are computed mostly on like periodic basis and pushed to a central place, right? Only in a very rare circumstances we would that's called real-time machine learning or others. So only in those real-time machine learning cases we would like to use a streaming engine, but again there are high chances that the results might get slowed down. Therefore what we do is we use big data platforms to process and keep the data ready in one of the databases, or because the result of big data, the summary, the insights, the predictions, or any result of machine learning is generally smaller as compared to the raw data. Okay, therefore it's okay to store results in a database or in a NoSQL database or in a file and then present that file. Okay, did it make sense to you, Hiteshna? All right. Good, great question. Now moving ahead. Correct. Thank you, Gagan. You had already answered it for me. Hitesh's question is, how about real-time analysis and displaying will be storing in between, making it slower. All right. So real-time analysis is something which is decently hard. And what you do is you use different kind of other systems to do the real-time analysis. For example, you use a Redis kind of a database, which would provide you an in-memory way of keeping data and so on. We will get into more details as we go through the session and learn how each individual component sets in. Good. Moving ahead, the next component is Mahat. You see this one on this side, Mahat. So what is Mahat? For workloads of machine learning, so the tool that I built it in Mobi was a recommendation engine, and we were churning around 200 terabytes data to give recommendations to our end users. In that case, we use Mahat. Mahat took raw data from HDFS in the form of comma separated values and generated the results into HDFS, which we pulled to our ad serving engine and displayed it to end user. Okay, so that's Mahat. Mahat is basically a library of functions which under the hood use MapReduce and process really humongous data. It's library function for machine learning like recommendations and other things. Okay, recommendations, regression, and so on. Okay, now the next component is workflow. So it's very clear that your project would involve more than one component at a time. Okay, your project might be like this: copy the data from web servers into HDFS, okay, and then clean the data using say Hive or MapReduce, and then process the data using Mahat, and whatever is the result, then that result again need to be reformatted into some other form using Hive. Then you give out that result to the end user, right? So if you see, if you look at it closely, it would have it would have so it would involve so many components. So how do we get this kind of work done on Hadoop? Simple answer is using Oozie. Oozie is a workflow system like Maven and Make or any other build tools. Oozie lets you stitch your job, which involves many works, and executes it periodically or at one time. Okay, so that's Oozie. And as an engineer, as a developer, you can also use command line interface or use Java or Python to operate on this. The other components which we have missed so far is Flume and Scoop. Flume is for copying data. Flume is a MapReduce job. Sorry, not Flume is Scoop is a MapReduce job. Flume is a continuously running engine which imports data from various sources into HDFS. So using Flume, you can actually push all of your web servers data. If you are running, say, 10 web servers or 15 web servers, you can run Flume on all of those web servers and push the data to Hadoop. So Flume is a key component when we talk about consolidating the entire data to a single place in HDFS. Okay, Flume keeps running all the time and keeps on pumping data to a single place. Okay, Flume does not perform any kind of translation or processing. It just copies data from one place to another continuously. Okay, I'll come back to your questions again. The next component is Scoop. What does Scoop do? Let's say your data is already lying in RDBMS. Okay, and you would like to copy that data to HDFS, or you would like to move that data to Hive. Okay, Hive does provide you this tabular structure with which you can store data in HDFS itself, and the metadata of Hive goes into SQL. Okay, so If you have this existing database tables and you would like to move that data into Hadoop, then you can use Scoop. The structured data can be copied to HDFS using Scoop. Scoop is batch-wise, okay, and Scoop under the hood uses MapReduce. Okay, Scoop uses MapReduce in order to copy the data from all machines to a single place. Okay, Flume is like a message queue. Answer is no, because it's a unidirectional, and the it basically brings data from all points to only one point. Okay. But it does have some qualities of a queue. That's right, Gagandeep. SQL does convert tables to files for HDFS. Yes. Basically, it copies and converts. Now, there was a question from Saris. Before that, there was a question from Srini. For data security, securing personal identification, okay, what is the best practice to use in Hadoop? Okay, and yeah, Ranger is good idea, definitely good idea to use. And I would strongly suggest that you break down your record into two parts. One is called super confidential, such as credit card number, then secondary confidential, such as SSN and name, and third is third is low confidential, such as the say purchasing history. So what we do is in case of data security, we break down data into 3 or 4 parts, and we make these parts available only to different people. Okay, for others who we do not want to give the actual data, let's say developers, we would like to do the processing, but we would not like to see somebody's confidential data. We mask the confidential detail and act on user ID instead of users details. Okay, all right, good question, Srini. Now, a question from Sari is, please repeat Uzi. Uzi is a workflow system because your project might involve one or more of these components interacting with one or more of these components, and you would also like to execute your job involving many components every night or at certain period. In those kind of cases, it's better to use Uzi. Uzi is a workflow system. Workflow as in like Ant, Maven, or the make, those kind of tool. It's for developers to use in order to execute their jobs. Hitesh's question is, if Kafka is a superset of Flume and Scoop? No, actually these Flume and Scoop are very specialized tools. Scoop is for in and out of Hadoop to the databases, while Flume is to gather all the data from various places into HDFS. Akanksha's question is, can you explain what is the use of NoSQL database over HDFS? How it provides reads faster? So NoSQL does not provide only the reads, it does not provide reads faster, but what it provides is, just like database, it provides you database tables in which you can update data, delete records, update records, add more columns to it, and so on. That's what NoSQL database provides. Okay, so with respect to reading data, HDFS would all be faster, right? But to convert a file into records would require processing every time. Therefore, it's better to keep the data structured, sometimes in the form of NoSQL data stores such as HBase. Okay, do I make sense to you, Akanksha? All right, now going ahead. All right. So you can drop me a message. I can answer more. A question from Krupa is, what is Kafka? All right. Let me explain again. So what is the difference? What is the advantage of MySQL over file system? That's the question, right? Question is, what's the advantage of HBase over HDFS? Advantage is HBase lets you manipulate structured data, while HDFS is append only kind of file system. If you have to update a particular record, you'll have to rewrite the entire file. That's the difference between HBase and HDFS. Divya's question is, HBase provides update, delete data. Will Hive provide the same? Hive has started providing the same, okay, by the way of a new format. Earlier, it was only a processing engine. All right. Flume is like a message queue. No. Does Scoop convert tables? Yes. Is there any connector available to connect ERP database like SAP, Oracle, or to HDFS? There are connectors, of course. If ERP, SAP, Oracle, they all expose the RDBMS interface. Okay, we call it JDBC. So these all provide JDBC connector, and hence Scoop can be used with ERP, Oracle, SAP, okay, in order to copy data from there into HDFS. Okay, good. All right, I hope that I hope I've answered your question, MSP. You'll generally use Scoop. Okay. Also, for those who are wondering, so MapReduce, the function map and reduce, they are proper Java code. Okay, just that they get executed in distributed fashion in certain order. Therefore, anything a Java program can do, a MapReduce can do. All right. Similarly, you can also write MapReduce programs in other languages, which essentially get executed like a system call. Danny's question is, did you say you cannot update HDFS without uploading the entire record? Yes. You cannot update a particular line in a file. You'll have to rewrite the entire file in HDFS. Okay. Just like in a file system, if you have to modify a file, right? If you have to modify a file and you delete a line and add one more line, or delete say 5 lines out of a file, you will have to rewrite the entire file. Do it make sense to you, Danny? All right, great, great. Hitesh is saying, can you say about Kafka? Kafka is a message queue, just like enterprise buses, whereby the organization can communicate. All right. I think it's important to talk about Kafka. Let me just take 1 more minute. All right. Can you say about Kafka? Let me answer this question. It's an important one, and most of you would be asking. There is a tool called Kafka. Kafka lets you create a queue organization-wide. Now, what's the point of it? Let me give you an example. When an order is placed on Amazon's website, right? The moment an order is placed, many departments have to be informed. One way is that we One way is that we who are maintaining the website make an API call to these all other departments inside Amazon. One way is that we make a call to their API and inform that one sale has happened and this is what needs to be delivered. But that'll be a very tight coupling, right? There'll be very tight, as in if there are new departments created inside Amazon, or there are new teams who want to be not notified about a particular thing, they have to come to the website team and always update the website's code in order to get notified. Instead, what people at enterprise level have realized and have embraced for quite some time is creating an organization-wide queue in which there are speakers and there are listeners, like a big notice board in a company, whereby people put the notices and other people read it. In the similar way, we create something called enterprise queues. And one of the best queues in today's time is Kafka. In Kafka, there are many writers on one end, and then there are many readers on the other end. There are RabbitMQ, for example, and and basically such kind of software is continuous. On one end, there is a data coming in, on the other end, there can be any number of listeners for that data. and and inside Kafka there is an idea called topics, so that many people can create many kind of topic and talk over it. Okay, there are producers on a topic and there are consumers of a topic. So somebody who speaks or puts data on each topic, that's called producer. The people who read the data, who are listening for that topic, are called consumers. Okay, so that's Kafka. I hope I made sense to you. So inside Amazon, when the sale is made, the one record is kept inside a queue. We use something called SQS queue at Amazon, similar to Kafka, but it's not. I mean, it's very much specific to Amazon, although it's available to all. So as soon as the sale is made, we put that information, a record in SQS there in the queue, and many people who want to get notified that the sale is made. For example, the availability team would need to update that now total item available are one less, right? Similarly, the pricing team has to figure out that the pricing can be increased or decreased because of the sale. At the same time, recommendations team would like to read from this queue to keep a note of what this person's next recommendation should be. At the same time, there would be a credit card fraud team, which will basically try to understand whether this transaction is a fraudulent transaction or it makes sense. There will be other team which is responsible for sending the emails to the user, right? They will also read from the same queue. So same packet, same information is being read by so many people without the work of the website. Otherwise, website has to keep these hooks in order to inform all. Okay, so it's like an event bus on an organization level. That's the use of a queue. Okay, a question from Hitesh. Are there any limitations on the size of topic data? Generally, no. Okay, so far not. There might be hard requirements, but I've not come to. Yes, we are going to explain Spark and its component today. Kushal's question is, what if an event fail? Okay, there could be many situations where the event could fail, but the good part is the systems like Kafka, they come with a great resilience. Okay, we will go into more details later. I'll plan a event on Kafka. Okay, I'll plan a talk on Kafka soon, so that we can learn Kafka together, and we will go into more details on the various like how does the failure handled at Kafka level. Okay. Events are not rolled back. Events are once done, they're done. Okay. All right. Now let's move ahead to Spark. So what is Spark? We talked about Spark briefly here. That Spark runs on top of Yarn. Okay. But Spark in itself is a big system. It has come with more and more components. So Apache Spark, it's a part of Apache, not Apache Hadoop. Okay, it's a fast and general engine for large-scale data processing. Okay, which means it does not provide you a storage. Okay, it's very important to notice this. So most of us think that Spark provides a storage. No, it is a processing engine. What's a processing? Processing is running a program, running a piece of logic. That's processing. Okay. It's really fast MapReduce. Okay, they took MapReduce to a different level altogether. They made it extremely fast with new set of paradigms. It's around 1,000 times, 100 times faster than Hadoop if it's being run in the memory. But generally, memory is too precious to run all the workload. Therefore, it's also run on the disk, and as per their numbers, it is 10 times faster on the disk. Why it's faster? Two answers. One is architecture. Second, they utilize RAM whenever possible. Okay, it builds on similar paradigm like MapReduce. It's well integrated with Hadoop. Okay, why? Because Yarn made it possible that any program can run on top of Hadoop, and therefore it also runs on top of Yarn. Okay, now what the Spark guys were pretty smart, are pretty smart. What they did was they made it possible to run a Spark on all kinds of resource managers. Yarn is not only the one who can execute things on the network. There are many others, right? For example, there is something called Apache Mesos, which is also a specialized and independent tool to execute things in a network and keep a track of who is busy and who is free. That's resource manager. So Apache Mesos is also a good resource manager. So Spark, the Spark guys made it possible to run Spark on top of Yarn and Mesos and on EC2, as well as if you do not have an existing Hadoop installation or Mesos installation, or you don't have Amazon EC2, you can still use Spark by using their standalone resource manager. Okay, these are called resource manager. All right, now instead of providing the storage themselves, what they did was they provided connectors to all possible systems. So using a Spark, you can read the data from HDFS, HBase, Hive, Tachyon, Cassandra, and of course, JDBC. Using JDBC, you can read from all kinds of databases, whether you're using MySQL, Oracle, okay, or any other SQL database. All right. Now, on top of Spark, you have these data frames, these libraries, the secondary libraries. So the way you have Hive on top of MapReduce, right? Similarly, on top of Spark, you have many other libraries. Okay. So like the data frames of R or database tables of SQL database, we have data frames in Spark. So instead of writing if-else conditions and for each loops or writing the code, you write queries on top of data frames. And this is so powerful that you can switch between the code and the SQL query seamlessly. So data frames is actually very great way of processing data. So those who are coming from, say, our backgrounds or coming from databases background, they should master or learn data frames pretty well, and they will enjoy data frames because data frames combine the power of usual functional programming, R kind of programming, and SQL kind of programming. So data frames, which was created as part of Spark SQL, is actually very powerful. Say you have to group certain data by certain field, or you want to filter certain data by certain criteria. You can use data frame very simply. You create a data frame over a file saved at some of the data sources, and then you can run the query using data frame. And internally, data frame uses Sparks. Okay, all right. So next is streaming. For the cases where you want to process data continuously, you would like to use Spark's streaming wrapper. Streaming is another program which internally keep on making calls to Spark. Okay, so all it does is it connects to a data source and keep creating these small buckets of data, and that bucket of data it hands over to Spark. Okay, we will learn each of these components in as part of the course. Then there is MLlib. MLlib is a machine learning library. It is full of very complex algorithms which are hard to implement, but they are off the shelf available to us. So MLlib is probably the most complete and most powerful library for distributed machine learning. Meaning, if you have humongous data and you want to do the uh, machine learning on that humongous data, you will use MLlib. Then we have GraphX. GraphX is a package, is a very powerful package if you want to process, if you would like to process the the graph, like social graph. In those cases, you will use the GraphX. Now, as an end user, you can interact with these tools either using SQL, R, Java, Python. So if you're coming from Python background, you can use Spark comfortably. There's no problem at all. Similarly, Java and R. So you can, and of course Scala, because in Scala the Spark is written, so that's the first level of support. So the general question which people ask at this point is, which language should we pick? My strong suggestion is we pick Scala. Earlier when I ran my courses, I did in Python, right? But soon enough we realized that one, Python was slower than Scala. Second, although that speed did not matter much, but what mattered was the GraphX was not available in Python. It was only available in Scala. Okay, a question from Christopher. What is Tachyon? Tachyon is another file system like HDFS. Okay, Tachyon is another file system like HDFS. All right. So any questions at this point? A question from Yashwant. Sometimes queries are getting skipped, bypassing. When any of the SDFS cluster is down, do you think it is a drawback of resource manager to handle this? Can you ask this at our forum? Okay. So what we have done is we have created. I will open here. So if you go to CloudX Lab, all right. So I'll just go over what we have right now, and yeah, thank you, Ravi, for reminding that. Yes, we will move to CloudX Lab very soon. Okay. All right. Did I miss something? Gaurav's question is, could you explain the data frames benefit again? Time to understand why it would need traditional programming loops. Right. So with data frames, you can do computing using standard MapReduce or using R or SQL. That's the benefit of data frames. You can take a look in more details, and okay, we can discuss it in more details. Data frames make it possible to write the express the logic either in SQL or in R or in R kind of conditions, or writing standard MapReduce. Spark can connect to any RDBMS using JDBC. Yes, Anu. Can we move to CloudX Lab? We are left with 15 minutes. Yes, definitely, I would like to. So yes, so if you are interested in just the lab, you can enroll here. I'm already enrolled, so uh, I can explain. And if you are interested in enrolling for the live course or self-paced course, you can go to this page, okay, and enroll. All right. So here, so you can go to the course here, and yes, I'd like to give you a demo. Oh, still you're seeing the slides? Ouch. Let me share again. Okay, so all right, can you see my screen now? All right. So if you are interested in taking up the course is humongous, and we have self-paced course as well as the online instructor-led course. The online instructor course is already started. First class was today, and all right, and you can take a look at it here. Second is we have a discussion forum. Also, if you just want to enroll for a lab, you can enroll for a lab here on the home page. If you want to take a look at discussions, okay, if you have a question in mind and you want to ask it, you can ask it here. We put our whole effort in replying to your question, okay. And then we have some more learning tools like hands-on videos, projects, blog, etc. So you can take a look at our blog. Okay, so we keep on putting more and more information here in the blog, and this particular blog post is very popular and is quite useful to lots of people who are trying to build system. Okay, and yeah, let me go back here. So that was our blog. And there are hands-on videos that you can take a look at how to use CloudX Lab and some of the projects. Okay, but once you sign up, you will see My Lab. Okay, in the My Lab, there is lab credentials. Okay, here I have my credentials and I can log into Ambari. Ambari is an admin interface provided by Hortonworks. In order to see all the components, let me log in into Ambari with the, here's the copy password, paste password option. Okay, looks like my login is changed, but I'll just log in with another account for now. Okay. Oh, I shared it only with. All right. Okay, so you can see at this point that there is Ambari. In this you have HDFS and you have yarn, you have MapReduce, you have all these other components. Okay. At the same time, let's say you want to interact with any of this, you can use either Hue or command line interface. Okay. Here I have this HDFS browser. This is the file system, Hadoop's file system. Okay. This is the Hadoop's file system. And if I want to interact with Hive, I can interact with Hive using this and so on. Okay. So if you want to interact with Uzi, you can use this, pick this, and so on. All right. There are other tools as well. Okay. Now going back to my lab. Now the third one is Web Console. Using Web Console, you can interact with the console from the browser. You don't have to install Putty or any other solution. So this is the general console from where entire thing would happen. Okay, so you can, let's say I want to run Spark. I can run Spark Shell from here. Okay, so this is my Spark's interactive console. This is my Spark's interactive console. It is yet starting up. Now it is started. So I can interact with, let's say, I want to read file from HDFS here. Okay, I'm just trying to read a file from HDFS. Okay, I'm just giving some name to it. And so I've created this data set and I can run programs on top of it now. Okay, this is just a quick demo to all of you. Don't mind if you did not understand anything at this point. It's a simple, I'm just trying to show you other things. Also, we have tools like Jupyter and others, which you can take a look here. All right. So you can see the various components and use. All right. I hope that answers your question. There are a few questions that I missed answering you. Okay. Is the purpose of Hive, Kafka, and HBase same? I hope I answered that question. Kafka provides a kind of publisher subscriber kind of model, while Hive makes it possible to convert raw data, convert SQL queries into MapReduce. HBase lets you store very huge data into using NoSQL. HBase is a database and it lets you handle many queries and many records parallelly. Okay. The second question, which I have not answered, was the difference between Hadoop MapReduce and Spark MapReduce. Hadoop MapReduce is basically you write the entire job, submit and wait, while Spark MapReduce can be done interactively from console. Second, Hadoop's MapReduce is slightly slower than Spark's MapReduce. Next is Spark's MapReduce is far more sophisticated that you can combine multiple levels together. Okay. Any other questions that I have not answered yet? Okay. So feel free to ask questions at our forum as I showed you on our website. So if you go here, you can click on discussions or go to the course that is launching, or you can take a look at hands-on videos, take a look at the blog, take a look at the projects. And inside the my courses, if you are new to Linux, you can actually attend to this one. This is something we have written to help our users, but but it is quite useful to everyone. Okay. Yes, Darshan, they are quite with a heavy discount because the course is going to run for more than 14 or 16 sessions easily. Okay. Anyway, you can reach out to us at reach us at CloudXLab. Okay. All right. Next question is, can Kafka be linked to Spark streaming directly? Kafka can be linked to Spark. Yes, it can be, of course. So in the example that we have showed in the blog, we are reading data coming continuously in Kafka into Spark streaming. Okay. Spark processes in RAM and RAMs are expensive, then how it's better to use Spark? So not entire thing is in RAM. It uses the RAM adequately. Okay. It uses RAM adequately. And you can also tune it in order to optimize the RAM usage. Okay. The timing is for the class is same as what the session was. Okay. All right. Next question from Akanksha is, won't it be expensive or faster speed? It will be expensive if you consume entire RAM. All right. And okay. So, all right. Thank you very much. Those who have enrolled, they will get an email from our side. And this first session was free. The second session and onwards, for that you will have to enroll for the course. All right. and and most of our content is anyway open and available, just that the advanced topic is going to be something premium as of now. So Arish's question is, who is the faculty? Yes, I'll be the faculty for this course. Okay, we'll start tomorrow with Zookeeper and then HDFS. Okay, all right, great, Vikrant. Sorry, could you drop an email to reach us at CloudXLab? I think they will, one of my teammates would answer your question. Okay. Thank you all. Feel free, please come over to our discussion forum. We would love to answer all your questions. Okay. Or if you have a direct query related to the course enrollment, drop us an email at reachus@cloudxlab. We would love to answer your questions. We enjoy answering your question. There was a question regarding certifications. The course is tuned to the data engineer certification by Databricks and Hortonworks and Cloudera. So you will not have a problem attending to any of these certifications. Also, we provide our own certificate that you can display on LinkedIn or you can print. Okay. So this course actually covers multiple certificates. Okay, that's why the course is huge. That's why the course is huge, and it's probably the one of its own kind, because we are trying to cover with respect to what industry needs, not only what certificate needs. Okay, we try to focus more on what industry needs. Okay, all right. Thank you, everyone. It was great to have you here. And I can definitely assure you that if you actually do things on lab along with what we teach you in the session, it'll make you more comfortable with the technologies, and hence it'll be easier for you to change the job or pick a new job. Okay. So thank you, everyone. And you will get these slides as well as the videos in email. Okay. Yes, Saresh. It was a wonderful session. I had a great set of questions from you. And yes. No, not really. Not really. You don't have to actually, this will, so Sarish's question is, since we are not downloading or installing anything in order to learn, will it create any issues during interviews? Not at all. So the way the course is tuned is in order to, so it's not an administration course. It's a data engineer course or a data scientist course. Okay. And uh, uh, installing cluster is something not expected out of anybody. Okay, therefore it's better to learn on a real cluster than trying to install virtual machine, which anyway does not give any learning. Okay, so it's better to far better to learn on a real cluster than actually trying to download install virtual machines. Sankar's question is there any data scientist course? So we are planning data scientist course, but as of now, this course should help many data scientists who have good knowledge on statistics and good knowledge on the machine learning part. Okay, so this course will kind of help them understand the distributed computing and new genre of technology. Question from Saresh, what's the difference between CloudX Lab versus Amazon? Okay, I'll answer it very quickly. CloudX Lab is hosted on Amazon. Okay, with Amazon, you will have to buy so much. So if you buy so many machines, it will be too costly for you. And what we provide is an environment which has all the technology and everything ready for you. There's not much of a difference between Azure's implementation and AWS implementation, just that AWS has got far more services and is a little more mature in terms of the services. All right, great. Wonderful set of questions. I totally enjoyed the session. And feel free to come over to our discuss.cloudx lab and ask questions. We love to answer your questions. And we have a great set of alumni as well who would love to answer your questions. Great. Thank you, Ravi. I'm happy that you find it awesome. All right. Have a great day and a great week ahead. Thank you, Darshan. All right. Bye-bye. Have a great week ahead. Thank you, Ashutosh. All right. I'm happy that you found it good. Great. There's a class tomorrow for those who have enrolled for the course. Okay. Great. Great. Thank you, Naveen. Bye-bye. I'm going to end the meeting now. Have a great day.